At a mind-bending speed of 828,000 kilometers per hour, our entire solar system is racing through space, orbiting the center of the Milky Way galaxy. And yet, even at that unimaginable pace, it will take us 230 million years to complete just one full revolution around the galactic center. The last time Earth was in this same part of the galaxy, dinosaurs had just appeared. Since then, they've risen, ruled, and vanished, and in their place, humanity evolved, built civilizations, and looked up at the stars, sketching simple diagrams of our solar system, as a flat disk with planets neatly orbiting the sun. But that picture is wrong. Our solar system isn't flat. It isn't two-dimensional. It's a vast, dynamic, three-dimensional structure, twisting and tilting through space. And the real mystery is: what lies above and below it? What secrets hide in the unseen layers of our solar neighborhood? Let's dive deep, far beyond the orbits of the planets, into the unknown vertical dimension of our cosmic home. Here on Earth, the idea of up and down makes sense. Gravity pulls us toward the ground, the sky is above our heads. But in the infinite vastness of space, there is no up or down. There's no north, south, east, or west, only relative directions. To define above and below in space, astronomers use reference planes. For the solar system, that reference is the ecliptic plane, the imaginary flat sheet tracing the Earth's orbit around the Sun. But most other planets don't strictly follow this plane. Mars' orbit is tilted by about 2 degrees. Mercury tilts around 7 degrees. And Pluto, once our 9th planet, has a staggering tilt of 17 degrees. Some objects go even further. The near-Earth asteroid 3200 Phaeton tilts at 22 degrees. And Halley's Comet moves at an incredible 162 degrees, orbiting the Sun in the opposite direction of most planets. So our solar system is far from flat, it's a swirling, layered, three-dimensional architecture of orbits, tilts, and inclinations. Now imagine zooming out, way beyond the planets, until the entire Milky Way comes into view. Here, astronomers define another plane, the galactic plane, a colossal disk spanning 100,000 light-years across. From this galactic plane, we draw an imaginary line upward, at 90 degrees, to define the galactic North Pole, which points toward the constellation Coma Berenices. The opposite direction leads to the galactic South Pole, in Sculptor. But how can we even define north or south in a universe without directions? Back in 1959, the International Astronomical Union solved this by anchoring the galactic coordinate system to Earth's celestial poles, so that the galaxy's north roughly aligns with Earth's. Using this system, astronomers mapped the Milky Way's latitude and longitude, just as we map our planet. Now, let's return from the galactic scale to our solar system once more. Between the planets lies a subtle veil, a thin layer of dust and debris known as the interplanetary dust cloud, or the zodiacal cloud. It's made up of countless microscopic particles, the remains of shattered asteroids, disintegrated comets, and ancient collisions that shaped our solar history. This dust spreads not only along the ecliptic plane but also above and below it, forming a faint halo of cosmic residue that still drifts between worlds. Beyond the asteroid belt, giant planets like Jupiter and Saturn act as massive gravitational vacuums, capturing or clearing much of this dust into their rings or atmospheres. Further still lies the Kuiper belt, a frozen frontier 30 to 50 astronomical units from the Sun. One astronomical unit is the average distance between Earth and the Sun, about 150 million kilometers. Here dwell icy worlds like Pluto, Haumea, and Makemake, small, tilted, and chaotic, revealing how wild and scattered the outer solar system truly is. Beyond the Kuiper belt lies an even stranger realm, the scattered disk. This region, stretching from 30 to 100 Australian dollars, is home to the trans-Neptunian objects, ancient remnants that Neptune's gravity once flung off course. Many have bizarre, inclined orbits, like Eris and 2004 XR190, tilting more than 45 degrees from the ecliptic. And somewhere out there, hidden in the dark, might lurk the mysterious Planet 9, a world so distant and massive that it could be warping entire orbits around it. So far, it's only a theory, but if it exists, it lies in this scattered chaos. Beyond even that, we reach the Oort cloud, the outermost frontier of our solar system. Astronomers believe this vast, spherical shell of trillions of icy bodies encircles the Sun from about 20,000 to 200,000 astronomical units away, nearly 3.2 light-years into space. We've never seen it directly, but the evidence is there, in comets that swoop in from incredible distances, taking hundreds of thousands of years to complete a single orbit. The Oort cloud extends both above and below the ecliptic plane, a frozen halo marking the true edge of the Sun's influence. Now, if we look above the Sun's north pole itself, we find a realm charged with energy, filled with magnetic fields and streams of plasma called solar winds. These winds erupt from the Sun's poles, flowing outward like rivers of charged particles that fill the solar system, forming a vast protective bubble known as the heliosphere. This heliosphere defines the boundary between our Sun's domain and the interstellar space beyond. Its outermost edge, where solar wind meets interstellar matter, is called the heliopause. In 2012, NASA's Voyager 1 became the first spacecraft to cross this boundary, traveling above the ecliptic plane. In 2018, Voyager 2 followed, crossing below it, marking humanity's first steps into true interstellar space. As our heliosphere drifts through the galaxy, it passes through wispy clouds of interstellar gas, one of which is known as the Local Interstellar Cloud, or LIC. Our solar system is moving through this region right now, a patch of space roughly 30 light-years wide, part of an even larger structure called the local bubble. The local bubble spans 1,000 light-years, likely carved out millions of years ago by multiple supernova explosions that blew away surrounding gas, leaving a vast, hot, low-density cavity filled with million-degree plasma. At the bubble's boundaries lie invisible walls of compressed gas, where our local region interacts with nearby structures like the Loop I superbubble and the North Galactic Spur, faint arcs that glow in radio and X-ray light, but remain unseen to the naked eye. And just when astronomers thought they'd mapped the galaxy's great layers, they discovered something even more staggering: the Fermi Bubbles. In 2010, NASA's Fermi Gamma Ray Telescope revealed two gigantic lobes of energy, ballooning 25,000 light-years above and below the Milky Way's center. They are so energetic that, if human eyes could see gamma rays, they would dominate our entire night sky. These bubbles likely formed from a colossal outburst, either a violent episode near our galaxy's central black hole, Sagittarius A*, or a massive starburst event in ancient times. Whatever their origin, they prove one thing. The Milky Way's energy doesn't just exist in the flat galactic disk, it surges upward and downward, expanding into the cosmic halo beyond. And yet, there's one final, invisible layer, the most mysterious of all. Surrounding and permeating everything, galaxies, stars, even us, is something we cannot see or touch: dark matter. It doesn't emit or reflect light, yet it makes up 85% of all matter in the universe. It's the invisible skeleton that holds galaxies together. Without it, the Milky Way would simply spin itself apart. Scientists believe our solar system is currently drifting through streams of this unseen substance, woven throughout the galactic plane, above and below, everywhere, yet undetectable, for now. Perhaps, hidden within dark matter, lies the next great secret, the key to understanding the structure of the universe itself. So the next time you look at a model of the solar system, neat, flat, and simple, remember. The truth is far more complex. Above and below that thin plane of orbits lie clouds of dust, icy bodies, magnetic storms, plasma winds, ancient explosions, and invisible matter, all shaping the reality of our cosmic home. We live not in a flat system, but in a celestial ocean, drifting through layers of energy, dust, and mystery. And as our solar system continues its long journey around the Milky Way, a voyage lasting hundreds of millions of years, we're still only beginning to understand what surrounds us. So, what other secrets do you think are hidden in the darkness above and below us? Let your imagination run wild, and maybe, someday, science will catch up.